Hello everyone. This is the year 11 webinar 10 on functions, and I'll quickly go through some of the basics. Obviously, not trying to cover everything about functions because it's a huge topic. So, a function. I like to think of a function as a magic box. So, it is a box. You give it a number, it spits out a different number. Well, not necessarily different. It spits out a number. You put it in, so that's the input, and the output. Output is, so if the function is f of x, the output is f of x, right? Sometimes you just say y is f of x. So it is a it is a machine that you give it an x, it spits out a different number f of x. So for example, if the function is like this, you give it a number, then it spits out a different number. So in this case, f of 4 is 11. Okay. The domain of a function is anything you can put in the function. The domain is the set of all inputs. The range is the set of all outputs. So for example, for this function, you're not allowed to put in negative numbers. So the domain would be anything that is greater or equal 0, x greater or equal 0. And the output, well, because square root of a positive number is a positive number, so you would have, so the range is anything that is greater or equal 0 as well. So we say y. So in this case, we, well, you rather than saying y, you can say g of x is greater or equal 0 because g of x is the output. A function versus not a function. So if you draw a graph is a set of points where with coordinates, so y, and the set of points where x and f of x, right? A graph is a set of points with coordinates x and f of x. So those are the coordinates of points, or just simply x, y. If y is obviously the value of the function. So x is independent and y is the value of the function, if that makes sense. A function versus not a function. So some relationships are not functions. And this is one of them. Because if the input is 4, then the output could be 2 or minus 2. Right? Because both, well, if x is 4, then y squared is 4. So y is plus or minus 2. So the output is ambiguous. If the output is ambiguous, then it's not a function. Okay. And the test for whether something is a function or not is the vertical line test. So for example, if you have a graph which looks like this, you draw vertical lines. Wherever you draw the vertical lines, it only crosses, any vertical line crosses the graph at most once. A vertical line crosses the graph at most once. So it is a function. It is a function. And if you have a graph which looks like this, for example, now here, a vertical line cuts the graph in 2 places. A vertical line cuts graph twice. So it's not a function. Okay, hopefully that makes sense. So basically, the when the if the input is known, you must know the output. If you don't know the output, or there are several options for the output, then it's not a function. It's just a relationship. Uh, okay, so this is a webinar. So there's a question in the chat. This is a webinar. This is for everyone. This is for everyone in year 11. This is different from your normal lessons with your tutor. All right. So if you can stay, this is recorded, so you can stay and listen. If you have something else to do, you can always watch the recording. But if you are year 11, you are definitely welcome to stay. Okay. If you're not year 11, well, stay if you want. I don't mind. Okay. Right. So these are functions. So some properties of a function. So functions can have functions can be increasing or decreasing. For example, you can have a function is increasing function, function. Uh, so the graph slopes upwards in a way. So if this is x, this is y. I mean, you're going uphill. Yeah. So if you think about an increasing function, what does it mean? Well, it goes up. If you from left to right, it goes up. A more strict definition: if you have two different values, x1 and x2, then this would be f of x1, and this would be f of x2. So f is increasing if x1, sorry, x2 greater than x1, if the function is increasing, means or is equivalent to, this is the equivalency statement. The function is increasing if and only uh, if x2 is greater than 1, then f of x2 is greater than f of x1. Okay. Or I'd say for any x2 greater than x1, f of x2 has to be greater than f of x1. So basically, if you step to the right, if you step to a bigger x, that brings you to a bigger y, right? So that's what means that function is increasing. If x is increasing and y is increasing as well. And function is decreasing if the in reverse is true. So decreasing function is decreasing function if for any x2 greater than x1, f of x2 is less than f of x1. So effectively, the function goes down, decreasing. Okay. When a function is increasing, it also means that the first derivative, so if f of x is differentiable, then the derivative of f of x is greater than 0. And for a decreasing function, Also, if the function is differentiable, no, you can't. Not all functions are differentiable. You can't differentiate all functions. Some of them don't have a derivative. If f of x is differentiable, um, differentiable, then the derivative of x is negative. So negative derivative means decreasing function, as long as the derivative exists. I repeat myself. Okay, so let's dive into functions a little bit. So I've got 8 very similar problems to the problems in the assignment. Some of them are scarily similar. Hopefully, you'll find it useful. Okay, I'll just move this here. Okay, so we have a function. Determine the range of the function. But before we even begin, we would like to talk about the domain. Domain. When you think about the domain of a function, well, so what can you put in? Well, obviously here, well, what can you put instead of x? Well, you can put anything as long as you're not dividing by 0 in this particular case. So you can't divide by 0. So x squared minus 9 must not equal 0. Or otherwise, x squared must not equal 9. So x must not equal -3. Otherwise, x is any number. So you can say x is any real number, but not equal to 3, 2 plus or -3. Okay. So what happens at this when x approaches 3? Well, what happens when x approaches 3? Well, if you start thinking about it, well, let's say x is greater than x is let's say x is 3.1. Then you have a small number, a very small positive number on the bottom. So you get something like y is, well, you can use a calculator. Why not? 6 divided by 3.1, 6 by 3.1 squared minus 9 plus 2. And that's 11. Y is 11.8. If x is 3.01, then y is 102 something. If x is 3.001, so we're getting close and close to 0, to 3, y is 1001. So you can see as x approaches 3, y approaches infinity. Interesting. So that's what we call a vertical asymptote. So sketching usually helps. So if you have 1, 2, 3, -1, -2, -3, so 3, -3. So when x approaches 3, y goes really, really big. So that's an asymptote like this. Okay. Well, you can use similar logic. If you do x is 2.9, y would be, I think it's going to be minus something, 2.9. It's actually -8.16. If x is 2.9999, if if x is 2.9999, y is negative 9,998. So you get a really negative number. That means that when you approach 3, but from the other side, you go to negative infinity. So as x tends to 3, we say as x tends to 3 plus 0, so and 3 minus 0. As x tends to 3 minus 0, y tends to negative infinity. Ooh, interesting. You can use a similar logic here. When you approach 3 from this end, you go to infinity, plus infinity, and here you go to minus infinity. So it looks like the graph should have a maximum point somewhere in the middle. And I wonder what's happening when x becomes really big. So what this is called analysis of functions. So what I'm doing is I'm analyzing what's going on with this expression. And I know that if x gets close to 3 plus 0, so 3 plus 0 means 3 plus something really, really small, y goes to plus infinity. If x, okay, why should I don't want to repeat myself. It's fine. Then what happens as x becomes really, really big? If x tends to plus infinity. Think about it. Y equals 6 x squared minus 9 plus 2. What happens to y if x becomes really, really big? Can somebody help me with that? Does it? Does it though? Tends to 2, correct? Because look, if this thing becomes really, really big, is 6 divided by something unimaginably big, that's 0. So this whole thing tends to 0. Plus 2, so y tends to 2. Now, if x tends to negative infinity, well, that also tends to 2 because that's also 0. Okay, so that's your asymptote. So 2 is your horizontal asymptote. So it looks like the graph will be like this. Like this. Now we need to find, well, it looks like the function is even. What does it mean that the function is even? So f of x is even if f of negative x is equal to f of x. In this case, f of x is 6 divided by x squared minus 9 plus 2. I hope I haven't made a mistake. Yes, plus 2. So it's trying f of negative x. F of negative x is 6 divided by minus x squared minus 9 plus 2, which is the same as plus 2, which is the same as f of x. So it is even. And when a function is even, that it has a line of symmetry. Even functions have a line of symmetry, which is x equals 0. Basically, an even function is symmetrical like this. Yeah, so this is x, this is minus x, and they will always be equal. So f of x is equal to f of minus x. Even functions have a line of symmetry. Yeah, and that means we only need to find f of 0 would be the maximum. You don't, yeah. So it does look like it's symmetrical. So y is biggest when the numerator okay between -3 and 3 between -3 and 3 the function is wait a second. If you consider this bit x squared plus 9, if you consider this bit is largest when x is 0, how does that work between -3 and 3? Because this thing is negative, is yes, so negative. So if you want the largest value of this expression, then you want to divide by the most negative number, if that makes sense. Most negative possible number. Yes, and this number is -9. I hope that makes sense. And well, we can check. We can check that. Yes, so this thing is negative. We know that between -3 and 3. So for x between -3 and 3. For x like that, right? This expression is negative, and it's going to be the largest when this bit is the smallest. Yeah, okay. When x is 0. And that means that max value, or just simply f of 0. F of 0 is 6 divided by 0 squared minus 9 plus 2, which is negative 1 point, negative 6 over 9 plus 2, which is 18 minus 6, 12 over 9, which is divided by 3, 4/3. 4/3. So it's just above. So that's 4/3. So the graph goes like this. Okay. And one more useful thing to talk about is the zeros. So what are these points? And so zeros of f of x. So this is where f of x is equal to 0. So f of x is equal to 0. So that's 6 divided by x squared minus 9 is plus 2 is equal to 0. So you would have 6 divided by x squared minus 9 equals -2. That means 6 is equal to -2x squared plus 18. 2x squared equals to 12. X squared equals to 6. X is plus or minus √6. So this is point √6. So that's more than 2. Okay, so slightly off. √6 minus √6, and this is plus √6. So you can have, the graph looks like this. Now, this is a very important skill. Being able to draw a graph of function is one of the most typical questions at a university interview. So I do recommend practice drawing graphs, and of course, you can always check yourself and open up Desmos, just type in your graph, 6 over x squared minus 9 plus 2, and you can see this graph here. Okay. Now, when preparing this webinar, I have not done this graph. I did it on the go. And this is the kind of question you can expect on a university interview. So, yeah. Cool. Let's move on. Simplify the following expressions stating any necessary restrictions on x. Okay. Well, arc sine x plus arc cos x. Well, first of all, what do we know about arc sine x? So f of x equal arc sine x. Well, we know that domain for arc sine is x is less than or equal negative pi, and less than or equal, is it pi over 2? I think pi over 2 and pi over 2. Yes. And the range is negative 1 y1. Now, if you have g of x arc cos x, then the domain is from 0 to pi, and the range is from -1 to 1. And this comes from the graph. If you draw the graph over arc sine, the graph over arc sine looks like this. And so this is -1. Sorry, I think I've messed up. Domain -1, 1, and the range is from yes, the other way around. Sorry, minus pi over 2 and pi over 2. Okay, so this is the arcsine function. This is 1. This is -1. And then this is minus pi over 2. And this is pi over 2. Now for arc cos, the domain is -1 to 1. 1. And the range is from 0 to pi. Yeah, that makes more sense. Okay, so we have pi over 2, pi 1 -1. This is the graph of arc cos x, and this is arc sine x. Okay, you can check that. Y equals arc sine x. It does look like this. And y equals arc cos x. It looks like this. So two graphs that look like this. Cool. So the restrictions on x, well, x has to be between that. For both, it has the same restrictions on x. So x is greater or equal -1, 1. Then what do we do with arc sine x plus arc cos x? Well, there are different approaches that you can take. You can use trig. You can use a right angle triangle. Right. So let's say you have a right angle triangle with sides A, B, and C. And this angle, let's call it theta 1. You can say that arc sine theta 1, sorry, sine theta 1, theta 1, sine theta 1 is using SOHCAHTOA, sine theta 1 is B over C. And that means that theta 1 is arc sine B over C. Okay. If you take the second angle, theta 2, you can say that cos theta 2, cosine of theta 2, is cosine theta 2 is B over C. And theta 2 is arc cos B over C. Now let B over C equals X, and we get theta 1 plus theta 2 is equal to arc sine X plus arc cos X. Now, in a right angle triangle, what is theta 1 plus theta 2? Yes, Cheyenne, you're correct. 90, well, 90 or pi over 2 in this particular case. It is pi over 2. So whatever theta 1 and theta 2 are, the sum will always be pi over 2. And that's the reason why we can simply say that this expression is equal to pi over 2. And x must equal to between -1 and 1. That's pretty cool. I hope you appreciate it. And let's check if that actually holds up. Look, if we look at the two graphs, so when if f of my f for -1, arc sine -1 plus arc cos -1. So that's the leftist point. Arc sine of -1 is negative pi over 2. And arc cos of -1 is pi, so plus pi. And that is, in fact, pi over 2. Let's check 0. Arc sine 0 plus arc cos 0. Well, arc sine 0 is 0. And arc cos 0 is pi over 2. So 0 plus pi over 2. So pi over 2. Arc sine 1 plus arc cos 1. Now I'm just having fun. So that's pi over 2 plus 0, because arc cos 1 is 0, and that's pi over 2 as well. So whatever x is, the sum is pi over 2. And yeah. And that leads to an interesting thing. So one consequence of that, that arc sine x is equal to pi over 2 minus arc cos x. Okay. B. Arc sine square root of 1 minus x squared. We need to simplify that. Well, let's say that let y equal arc sine square root of 1 minus x squared. Then that means sine y is square root of 1 minus x squared. Square it, so sine squared y equals 1 minus x squared. X squared is 1 minus sine squared y, but that's equal to cos. We already know that this is cos squared y. And x is cos y. Now, could x be negative? Well, yes, surely it could be negative, plus minus cos y. And oh, um, cos y equals to plus or minus x. So y is arc cos plus minus x. Sorry, what are we trying to achieve? I kind of lost the track. Arc sine. Just a second. Oh, yeah, arc cos x. Um, no. Oh, of course, there are limitations. There are limitations on x. So because you can't, there's a square root. So this you can't take a negative number. Or you can't take the square root of negative number. So 1 minus x squared must be greater or equal to 0. So x squared must be less than or equal to 1. That means modulus x must less than or equal to 1. So x can only be between minus 1 and 1. And when you do that, y squared, instead of plus minus, you're allowed to use modulus x. Modulus x because it um, has to be positive. Okay, and then you can have our cos, yeah, our cos modulus x, where x is between minus 1 and 1 again. So in effect, so what we have achieved, that we say arc sine square root of 1 minus x squared is the same as arc cos modulus x. Okay, and let's see, tan arc sine. Let's skip this one. We don't have too much time, so I'm going to skip this one. It's quite a long one and not necessarily useful one for you. So let's move on to question 3. And because this is a big one, an important one. For each of the following functions, determine whether it's even, odd, or neither. Justify your answer and sketch each graph. Well, if you substitute sine, so y, so a, f of x, if, so a function is odd or even. A function is odd if f of x is f of negative x is equal to negative f of x, and even if f of negative x is equal to f of x with a plus. So these are the rules. And then a, so y is equal to sine x, or f of x is equal to sine x, sine x. Then f of negative x is equal to sine of negative x. Well, how would you do a sine of negative x? Well, you could use the relationship sine of a minus b is sine a cos b minus sine b cos a. Let's use that relationship, and let's use it in a tricky way. Sine 0 minus x, because minus x is the same as 0 minus x. I think you would agree with that, right? So sine 0 minus x is equal to sine 0 cos x minus sine x cos 0. And we know that sine 0 is 0, so this thing is 0. And we know that cos 0 is 1, and therefore this is minus sine x. I don't know how rigorous this proof is, but this is simply minus sine x. So that means, which is minus f of x. So sine x, f of x is sine x, is odd, is an odd function. And if you draw the graph of an odd function, it has point symmetry around the origin. And that means it's symmetrical. It has rotational symmetry over the origin, or point symmetry. It has rotational symmetry of order 2. No, symmetry, or point symmetry over the origin. Nice. So you can see that this is x, this is negative x. So f of negative x is minus f of x. So this is f of x, and this is minus f of x. Beautiful. Next one. Y is modulus x sine x, so b. Y is modulus x. Okay, y. F of x is modulus x sine x. So we substitute negative x. F of negative x is equal to modulus of negative x sine of negative x. Well, modulus of negative x is the same as modulus x, so you don't you can just drop the minus, because modulus of negative 3 is the same as modulus 3. So that's that. And we already know that sine of negative x is minus sine of x, which is negative f of x. So that's also odd. And now they're asking to sketch the graph. Well, so it's a sine graph, but it is multiplied by the modulus. So it's the maximum, it's like the amplitude. The amplitude of the sine graph is like this. And it's gonna go like this. Um, It's going to be a sine graph with an ever increasing amplitude. Let's see how it looks like. Equals modulus x sine x. Oh, makes your eyes. And if you draw the line, y equals plus minus modulus x, and then oh, we can do that. Hey, you can see it's a beautiful graph. Okay. So modulus x is like the amplitude of the sine. So the sine gets stretched, but the further you go, the more it gets stretched. Right, C, sine x minus 1. C sine x minus 1. C sine x minus 1. So that's f of x. F of negative x is going to be sine of minus x minus 1, which is nothing, which is not related to the previous one. It's not equal to f of x, and it's not equal to minus f of x. Therefore, it's not odd or even, not even or odd. And if you sketch the graph, well, it's just a sine graph shifted by 1 to the right. So just like this. Like this. So it's not no symmetry. No symmetry. In origin or the y-axis. Ah, yeah. Next one. D. y equals x squared modulus x. Once again, it's f of x. F of negative x, so if you substitute negative x, it's going to be negative x squared multiplied by negative x. Well, negative x squared is the same as x squared, and modulus of negative x is modulus x, so that's actually equal to f of x. So that means it is even. And if you draw the graph, you will see that the function looks like this. So it's always positive. It's always positive. So x is any real number, and y must be greater or equals to 0 because you can't have a negative value. And it's also symmetrical. So it's going to be like this. Oh, it's actually a parabola. Let's see if that is in fact the case. It's y equals x squared modulus x. And yes, looks just like a parabola, except it's steeper. It's like a cubic parabola. It's like a cubic parabola, but without the negative side. So it's sort of, if you remove this is a cubic parabola. Now, if you make it always positive, then it becomes this. Nice. D, E. Can a function be odd and even at the same time? Yes, y equals 0, the trivial function. Y equals 0 is both even and odd. Yeah. And E. y equal modulus x plus 2 minus x minus 2. Right, so if you find f of negative x is going to be minus x plus 2 minus x minus 2. And this is a bit tricky, but you can do this: minus x minus 2 a minus modulus minus x plus 2. And if you take the minus out, because, well, modulus of a negative number is same as the modulus. So modulus of negative a will always be equal modulus a, right? So modulus of that is modulus of x minus 2 minus modulus of x plus 2. So it is, and it's also minus, open bracket, x plus 2 minus x minus 2. So this function is actually, so which is minus, it's minus the original function. So it is odd. And that's a beautiful result. Now sketching. I don't want to sketch it by myself. I'll just use my good friend Desmo's x plus 2 minus x minus 2. Is it? Plus 2 minus, yes. And you can see that it is definitely an odd function because it has symmetry over, it has point symmetry over the line. It's symmetrical. It has a rotational symmetry, right? So because if you rotate it 180 degrees, it looks the same. So that means it is odd. Beautiful. Next problem. Oh, that's problem 8. I suspect we won't have enough time to do everything. I'm so excited with functions. And all right. 4. The function is defined whenever the expression under the square root is non-negative. And state the domain of f and determine the intervals in which the functions is increasing and decreasing. Right. So the domain that x multiplied by 4 minus x multiplied by x plus 1 must be non-negative, must be greater or equal to 0. So when does that happen? Well, we have three numbers. And they can all be positive or negative. So in order for this to be positive, we have to say, well, either they all have to be positive, so x greater or equal to 0, 4 minus x greater or equal to 0, x plus 1 greater or equal to 0, right? Or exactly, or any two can be negative, right? Because we can only have a situation where it's plus plus plus, plus minus minus, minus plus minus, and minus minus plus. So there are 4 possibilities. Right, so either then x greater 0, 4 minus x less than 0, and x plus 1 is less than 0, or x is less than 0, 4 minus x is greater than 0, and x plus 1 is less than 0, or x is greater than 0, 4 minus x x less than 0, 4 minus x less than 0, and x plus 1 is greater than 0. So there are 4 possibilities, and let's calculate them. So x greater than 0, x less than or equal to 4, x greater or equal to -1, or x greater 0, x greater or equal 4, x less than equal to -1, or x is negative, x is less than or equal 4, and x is less than or equal to -1, or x is less than 0, x is greater than 4, and x is greater than -1. Okay, so this one is not possible. You can't have x greater than 4 and less than 0 at the same time. Not possible. Less than 0, less than 4, and less than -1. That is possible, and that is only true when x is less than -1. Greater 0, greater 4, less than -1. Not possible. Greater 0, less than 4, greater than -1. So that happens between 0 and 4, right? Only numbers between 0 and 4 satisfy all 3 conditions. Only numbers which are less than -1 satisfy all 3 conditions. These conditions are impossible to satisfy. You can't be greater than 0 and less than -1 at the same time. So these are the possible values. So this is the domain. So domain is x is less than -1, or x from 0 to 4. So that is the domain. Say the domain and determine the intervals which the function is increasing and decreasing. Oh, well, function is increasing if the derivative is positive. Okay, so we can say we can find the derivative of x. And to do this, we need to find we need to simplify. We need to open the brackets. So square root of x multiplied by 4x plus 4 minus x squared minus x, which is square root of 4x squared plus 4x minus x cubed minus x squared, which is minus x cubed plus 3x squared plus 4x. And to find the derivative, we do 1/2 multiplied by minus x cubed plus 3x squared plus 4x to the power minus 1/2 multiplied by the derivative of that. So minus x cubed plus, no, minus 3x squared, the derivative of that. I'm using the chain rule here, plus 6x plus 4. And that must be positive. That must be positive. And then this is a square root, so that's always greater than 0, greater or equal to 0. So we always greater than 0. So we don't care about that. So we have minus 3x squared. So f is increasing if minus 3x squared plus 6x plus 4 is greater than 0. And I can factorize that. And 3 minus 3, 6, 4. Okay. X1 is equal to 3 plus root 21 over 3, and x2 is 3 minus root 21 over 3. And if you sketch the graph of that function, so goes like this. So it's 3 minus root 21 over 3. This is 3 plus root 21 over 3. So that is about negative 0.5. And so that's 0. This is negative 1. And this is 2. The 4 is here. So the function only exists here and here. And it's increasing on this interval. So it's increasing here. It's decreasing, decreasing. Right, so increasing when x is greater from 0 to 3 plus root 21 over 3. Decreasing when x is less than -1, or x is from 3 plus root 21 over 3 to 4. Nice. Okay, so decreasing, increasing when the derivative is positive, and decreasing when the derivative is negative. Let's see if we can, if we've messed up. Equals square root of x 4 minus x. Ooh, what's going on? Y equals x 4 minus x and x plus 1. Nice. And you can see that until -1, it is decreasing, which is true. Decreasing from all the way to -1, decreasing, going down. Then increasing from 0 to this point, which is 3 plus root 21 over 3. So increasing. And then decreasing again from 3 plus root 21 over 3 down all the way down to 4. And that's how you do it. I hope you find this useful. I hope you're not overwhelmed with stuff at this time. It gets easier. It gets easier as you go along. Identify and classify all stationary points of the function. The stationary points, and that's where the derivative is 0. Okay, so differentiate, which is equal to 6x squared minus 18x plus 12. And that must equal to 0. So x squared minus 3x plus 2 equals 0. Special case, so x equals 1 and x equals to 2. So there's stationary points. Stationary points. Now, we can find the second derivative. Second derivative is, so if you differentiate that, so it's 12x minus 18. So the second derivative at point 1, when x is 1, is 12 minus 18, so that's -6. So that's minus less than 0. And that means that x equals 1 is a maximum. So y of 1, I substitute y of 1, so that's 2 minus 9 plus 12 plus 1. So that is 14, 15, 15 minus 9 is 6. So 1, 6 is a maximum point. Now, y second dash of 2, that's the second stationary point, is 24 minus 18, that is plus 6. That's positive, therefore x equals 2 is a minimum. then y of 2, find the value. So that's 2 times 8 minus 9 times 4 plus 12 times 2 plus 1. So that's 16 minus 36 plus 24 plus 1. That's negative 20 plus 24, so 4, 5. So 2, 5 is a maximum. Oh, a minimum, sorry. Minimum. And let's see if we can, what else can we do about the graph? Well, they're not asking to do anything else, and we don't really have time to do much else. So I'm just going to skip. I'm going to stop here. I'd like to find the zeros as well. 2x cubed y equals 2x cubed minus 9x squared plus 12x plus 1 minus 9x squared plus 12x plus 1. Is that plus 12x plus 1? Yes. And you can see that these are minimum and maximum. So what I've done is I've found these points. So this is a maximum and this is a minimum. Right, 5, 6. Question 6. Find the critical points of the function. Critical points is the same as stationary. Critical means stationary. So we start by finding the derivative, and to do this we use the chain rule. Remember that if u over v dash is equal to u dash v minus u v dash over v squared, so that's going to be x squared. Well, x is going to be 2x minus 10 multiplied by x squared minus 1 minus x squared minus 10x plus 9, 2x over x squared minus 1 squared. So y dash is 2x cubed minus 2x minus 10x squared plus 10 minus 2x cubed plus 20x squared minus 18x, 2x cubed cancels over x squared minus 1 squared. So y dash is 10x squared minus 20x plus 10. Is it? Yes. And that is x squared minus 1 squared. So that's equal to 10. Well, you can take 10 out. X squared minus 2x plus 1. We can factorize the bottom. So it's x minus 1 squared, x plus 1 squared. 10 x minus 1 squared divided by x minus 1 squared, x plus 1 squared. So it looks like the function doesn't have any critical points because the function doesn't exist. So x is not equal to -1 plus or minus 1. And if we simplify that, it's going to be x minus 1, x minus 9 divided by x minus 1, x plus 1. And Yeah, x minus 1 cancels, and you get x minus 9 divided by x plus 1, which could also be written as x plus 1 minus 10 divided by x plus 1, which is x plus 1 over x plus 1 minus 10 over x plus 1. And therefore, it's 1 minus 10 over x plus 1. So this is a graph of the function. This you can sketch it. So this is a transformation of one of the graph of y equals 1 over x. The graph is 1 over x. It looks like this. So it's 10. Then it's shifted to the left. That's negative 1. And then it's shifted up by negative 1, like this. 1. And then it's flipped. So it goes like this and 0. If you substitute 0 is minus 9. 0 minus 9. So it's here, minus 9. And if you want 0, uh, it's 1. It's 1 or 9. 1 or 9. Well, 1 doesn't work. The function doesn't exist at point 1. And 9. 9. 9. So it looks like this. So it goes all the way here, and then all the way here, except at point negative 1, it's point 1, 1, the function has a hole. It is undefined at this point. Undefined at x equals to 1. Why is it undefined? Because, well, if you substitute x equals 1, you get division by 0. Division by 0 is not possible. Right, so you have an asymptote, which is x equals negative 1, the asymptote y equals 1, the asymptote. So it looks like this. So it doesn't have any critical points. So no critical points. So because this cancels out, you get 10x plus 1 squared is never 0, so no critical points. So this is a mistake. It's not a big deal. But yeah, some functions have a local minimum, which goes like this, and a maximum like this. So a minimum, so if it has two branches like this, I don't know, like this, x and y. So the minimum can be greater than the maximum. There's no problem about it. If the graph has two different branches, the minimum point can be bigger than the maximum, which seems like a paradox, but no, it isn't, because the function is not continuous. And we've got two more. Oh, we might just make it. Find the range. Determine the domain, describe the asymptotic behavior, and sketch the graph of the following. So this is the kind of the deal. So this is the idea about working with functions, being able to analyze their behavior. And you always start with the domain. Well, here you have the denominator, which is x squared, is always non-negative. So x squared plus 1 is always positive. So there's no problem. And so there are no limitations. So for A, domain is x is any real number. Okay. Now we want to describe the asymptotic behavior. Asymptotic behavior, that means when x becomes really big. So when x becomes really, really big, so plus infinity. So you have x divided by x squared plus 1. Now, it's not always easy to describe the asymptotic behavior, but what we're going to do, we're going to divide both top and bottom by x. And this becomes x divided by x over x squared over x plus 1 over x. And it becomes 1 divided by x plus 1 over x. So if you want to find the limit as x tends to infinity of this expression, 1 over x plus 1 over x, you can see that this tends to 0. And so this tends to infinity. So the whole thing is the same as 1 over x. So that is, it tends to 1 over x, which is tends to 0. And also, you can see that when x is plus infinity, limit when x tends to negative infinity, you can also see that is x over x squared plus 1 is equal to 0. Also, if you can notice that f of minus x is minus x divided by minus x squared plus 1, which is minus x squared plus 1, which is negative f of x. So it is an odd function. So it's symmetrical. It has an axis of symmetry. And I think this might be enough to draw the graph. We know that if f of 0 is 0, f of 0 is 0, so we can plot this point here. Then we have the numerator increases, but so does the denominator. But the numerator increases faster in the beginning. So it reaches a maximum point and then goes to negative infinity. And on the left, like this. Let's describe the asymptotic behavior. They're not asking to find the minimum and maximum, but you could potentially find them. To find them, you would need to differentiate them. Critical points, let's do that. Critical points. So f dash of x, so you differentiate, and that is 1 multiplied by x squared plus 1 minus x multiplied by 2x divided by x squared plus 1 squared, and that's equal to 0 if x squared plus 1 minus 2x squared is equal to 0. So x squared is equal to 1, x is equal to plus or minus 1. All right, so this is 1 and this is minus 1. And the maximum point is, we just substitute 1 over 2, so 1/2, and this is minus 1/2. So this is the graph. The next one is B. Y is 1 over x minus x squared. Well, you can write it as 1 over x, 1 minus x. So you can see that the x is not equal to 0 and x is not equal to 1. So you can immediately remove those points. So there are vertical asymptotes. There are vertical asymptotes here and here. So that's x equals 1 and x equals 0. And then the function is very negative. Well, the function is negative when x is really big. Then this is positive and this is negative. So it's minus 0. So effectively, it's like goes like this. In between, so when it has a minimum point, it has a minimum point at 0.5, I suppose. Yeah, 0.5, 0.5 minus 0.25, so 4. 4. So the graph goes like this, and then it goes like this. Let's check. I might have made a mistake of 1 over x minus x squared. Oh, here it is. Yes, the minimum point is 0.54. Then we have these asymptotes. So I wasn't wrong, which is nice. And the third one, C. C is y equals x cos 1 over x. Okay, so what's happening with this bit? Well, if you look at the standard graph of cos, so y equals a multiplied by cos x, and then you have this is the amplitude, and yeah. So if you think about this graph in that sort of way, you can this is the amplitude of the function times cosine. So the amplitude is increasing. So this is the amplitude. And now 1 over x, as x becomes bigger, this tends to 0. As x tends to infinity, then cos 1 over x tends to cos 0, which is 1. So the asymptotic behavior for the function, when x is big, becomes 1. Now, so I'm assuming, because x can be big, so I'm assuming it approaches from the top. Oh, no, sorry. What am I saying? I'm being very silly. Now this thing becomes 1, and this is just, so it's just the asymptotic behavior just behaves like the line x equals y equals x, y equals x. Now it is an odd function because if you substitute -1, you will get minus that. So it's an odd function. So it goes like this. And then between the graph, so it should oscillate and should oscillate with an ever increasing frequency. Right, because as x tends to 0, cos x goes through many cycles. And let's see if that is in fact correct. Y equals x cos 1 over x. And yes, except, well, I was close enough, but not perfectly close. It does oscillate between these two lines slightly. Oh no, I think I'm spot on. Yeah, definitely. Spot on with the graph. Oh, lucky me. So just consider this graph first without the x. Like, how does that look like? This is cosine 1 over x, and you can see that it goes like this. So when x is really big, it's 1, and when x is very small, it's also 1. And in between, it oscillates, but the frequency increases as you approach 0 because the 1 over x becomes really big, and it goes through many cycles. Okay, brilliant. Now, a convenient way, when that's fine. That's you could also think of it this way. You know that if you have y equals a multiplied by cos bx, you can think of it in this way. So A is the amplitude, and B is the frequency. So if you write y equals x multiplied by cos 1 over x, you can rewrite it as x multiplied by cos 1 over x squared multiplied by x. So you can see that this value is the amplitude. So amplitude increases, and this is the frequency. So amplitude increases as x increases, and frequency increases as x decreases. Okay. Right. Find the range of these functions. I kind of ran out of time. But the best way to do it would be to sketch it, to sketch the graphs. And to sketch the graphs, you would need to find the critical points and find any asymptotes. So you need asymptotes, critical points, yeah, min, max, etc. And then you can find. If you really don't know, you could try try looking for any interesting points, zeros, of course, zeros, intercepts, any intercept. So you kind of start building a picture. Your final, what you're aiming for a graph, because looking at the graph is very easy to tell what the range is, right? Of course, you don't want to draw the graph point by point. That takes a long time. You want to kind of understand the behavior of the function. That's what we are trying to do. So please watch my previous webinars for some more insights. You can always go back to our website and find all the webinars from last year and the year before. I hope this was useful. Well, 10 of you stayed. Well, 8 of you stayed with me to the very end. That's really good. All right, so I'll see you, and I think next week. Let me double check. Webinars, year 11, and the next webinar is on the 27th. Yeah, so next week we're going to do reflection and refraction. All right, see you all next week.